Space is not the silent, empty picture you might believe. It is a stage, and right now, as you listen, it is hosting a show of bizarre and mind-bending events. We are going on a tour of 25 of the strangest happenings in the cosmos at this very moment. We will see stellar vampires draining their companions, phantom galaxies frozen in time, and planets made of diamond. By the end, you will see the universe not as a still painting, but as a chaotic and astonishingly weird movie playing all around us. What does it feel like to know the sky above is so full of silent, violent drama? Our first stop is a star system with a secret, a slow and violent theft happening in the constellation of Sagittarius, the Arrow. There, a tiny, dense white dwarf star is locked in a deadly dance with a larger, bloated companion. This is V Sagittarius, and the white dwarf is not a polite partner. It is a stellar vampire using its immense gravity to slowly, relentlessly siphon the very lifeblood, the hydrogen gas, from its larger neighbor. Imagine a cosmic parasite growing stronger by feeding on another. This stolen gas does not just disappear. It spirals down onto the surface of the white dwarf, compressing and heating until it ignites in a continuous, furious fusion reaction. This process makes the entire binary system grow brighter over time, a telltale sign of the cannibalism at work. Astronomers have tracked this brightening for over a century, watching the vampire's feast intensify. But this story has a spectacular and violent ending. The theft cannot go on forever. Calculations show that around the year 2083, the white dwarf will have stolen so much mass that it will trigger a runaway thermonuclear explosion. The two stars will merge in a cataclysmic event called a nova, so brilliant it may become the brightest star in our night sky for a month. We are living in the rare, quiet prelude to that cosmic detonation, watching a slow-motion stellar crime that will end in a blaze of light visible to the naked eye. It is a reminder that even the stars are not permanent, and their lives can end in acts of spectacular, drawn-out violence. But stellar vampires are not the only cosmic renegades. Far beyond our galaxy, a different kind of monster is on the loose. Astronomers have spotted a supermassive black hole, a gravitational titan with the mass of 20 million suns doing the unthinkable. It is not sitting quietly at the center of a galaxy. It is fleeing, hurtling through the dark emptiness between galaxies at a staggering speed. This is not a gentle drift, it is a full-blown escape, and the cause is as violent as it gets. The most likely scenario is a cosmic game of gravitational billiards involving three supermassive black holes. When two galaxies merge, their central black holes eventually spiral together. But if a third galaxy crashes the party, the chaotic dance can become unstable. In a rare slingshot maneuver, one of the black holes can be flung completely out of its galactic home, cast adrift into the intergalactic void. That is precisely what we are witnessing, a behemoth banished. The most astonishing part is the trail it leaves behind. As this rogue black hole plows through the incredibly thin gas that drifts between galaxies, it does not just pass through. Its immense gravity churns and compresses the gas like the bow wave of a colossal ship. And just like a speedboat churning up water in its wake, this compression triggers a miraculous and violent event, the birth of new stars. Telescopes reveal a brilliant, narrow trail of young, blue stars stretching for tens of thousands of light years, a stark contrast to the darkness around it. It is a surreal sight, a runaway engine of destruction paradoxically painting a stripe of creation across the cosmos. Right now, this exiled giant continues its lonely journey, forging a river of light from the darkness, a permanent scar from a galactic collision that happened eons ago. While some cosmic giants forge fire, others create a profound and absolute cold. Drifting through our own galactic neighborhood just 5,000 light-years away is a structure known as the Boomerang Nebula. It is not just another beautiful cloud of gas, it holds a record that is almost impossible to comprehend, the title of the coldest known place in the entire natural universe. This is the final, dramatic breath of a star not unlike our own sun, but playing out in a way that chills the very fabric of space. At the nebula's heart, an aging star has begun to die. It is shedding its outer layers in a violent, continuous gust, a stellar wind screaming outward at over 500,000 kilometers per hour. That is a wind moving fast enough to travel from Earth to the Moon in less than an hour. This incredible speed is the key to the deep freeze. In a process called adiabatic cooling, the gas expands into the near-perfect vacuum of space so rapidly that it cannot hold onto its own heat. Think of it like the coldest aerosol spray you have ever felt. When you press the nozzle, the gas inside expands quickly as it leaves the can, and that expansion instantly makes it feel freezing cold. The Boomerang Nebula is that principle operating on a cosmic, catastrophic scale. The result is a temperature that defies belief, a mere 1 degree above absolute zero, the theoretical point where all molecular motion stops. To put that in perspective, this dying star has created a pocket of space that is even colder than the faint, leftover glow from the Big Bang itself, the cosmic microwave background that permeates all of space. We are witnessing a star's last act not as an explosion of heat, but as a whisper of ultimate cold, sculpting its funeral shroud into a shape that appears to echo back through the eons, a frozen monument to a quiet and chilling end. This stellar wind of ultimate cold is a local phenomenon, but our entire galaxy is caught in a far larger and more violent dance. The Milky Way is not an island, it is a predator. Right now, our home galaxy is in the process of consuming a smaller neighbor, the Large Magellanic Cloud. This is not a future event, it is happening as you hear this. The immense gravitational pull of the Milky Way has already begun to tear at the smaller galaxy, distorting its shape and pulling long, faint streams of stars, gas, and dark matter out into a vast, diffuse halo that surrounds us. This process, galactic cannibalism, is a slow and brutal feast that has been underway for billions of years. The evidence is written in the sky. Telescopes have mapped these stellar streams, the ghostly remains of past meals, and they show the Large Magellanic Cloud's own halo is being violently stretched and merged with our own. It is a silent, gravitational war playing out over cosmic timescales, a reminder that even galaxies are not permanent structures but are constantly evolving, merging, and being reshaped by these colossal encounters. Yet, while our galaxy feasts, others have simply stopped. Drifting in the distant cosmos, there exists a class of cosmic ghosts known as relic or phantom galaxies. One of the most famous is NGC 1277. This galaxy is a fossil, a snapshot of the early universe frozen in time. Unlike the Milky Way, which continues to form new stars in its spiral arms, NGC 1277 has not given birth to a single new star in over 10 billion years. It is composed entirely of ancient, red stars that formed in a furious burst at the dawn of creation, and then, for reasons astronomers are still piecing together, everything just stopped. Perhaps it moved too quickly through a dense cluster of galaxies, having all the raw gas for new stars stripped away in a violent gravitational encounter. The result is an eerie, unchanging island of old suns, a museum piece from when the universe was young. So here we have two bizarre and concurrent truths about galactic life, the violently active and the profoundly still. One galaxy is being torn apart in a slow-motion collision, its material fueling new cycles of birth and death. Another has been sleeping for eons, a silent witness to cosmic history that itself has written nothing new. Both are real, both are happening now, and they represent the two extremes of existence in an ever-changing universe. From the silent fossils of ancient galaxies, we turn to a discovery so new it has no settled explanation. Scattered across the radio sky are faint, perfect circles like cosmic smoke rings blown on a scale beyond comprehension. Astronomers call them odd radio circles or ORCs, and they are utterly baffling. Each one is a gigantic, ghostly ring of radio waves encircling a distant galaxy at its center, yet with no visible structure in optical light to match. They are not supernova remnants, not the echoes of black hole jets. They are something entirely new, a class of object we did not even know existed until just a few years ago. The sheer scale is staggering. A single ORC can be 1,000,000 light-years across, 10 times the width of our entire Milky Way. Imagine a structure so vast it could swallow our local group of galaxies whole, and yet it is so faint and diffuse that it took our most sensitive radio telescopes to even notice it was there. What could possibly create such an immense circular imprint on the fabric of space? The leading theories are as dramatic as the objects themselves. One idea points to a titanic intergalactic shockwave. This could be the aftermath of two supermassive black holes merging in the central galaxy, an event so violent it sent a sphere of energy screaming out in all directions, lighting up the thin gas between galaxies like a neon sign. Another possibility is a spherical shell created by a frenzy of star birth. If the central galaxy experienced a colossal starburst, the combined winds from millions of exploding stars could have blown a perfect, expanding bubble into the surrounding void. Or perhaps it is something else entirely, a phenomenon we have not yet dreamed of. The most compelling part is that this is not ancient history. Right now, telescopes are actively focused on these enigmatic rings, collecting data to decipher their true nature. We are witnessing the first chapters of a cosmic mystery being written, a reminder that even with all our knowledge, the universe still holds profound surprises, waiting just outside the limits of our ordinary sight. But the cosmos is not just a place of violent explosions and ghostly rings, it is also a forge for the truly exotic. Orbiting a sun-like star just 41 light-years away is a world that seems pulled from the realm of fantasy, a super-Earth known as 55 Cancri. This is no rocky planet like our own. It is a world of unimaginable wealth and hellish conditions. Astronomers believe its composition is staggeringly carbon-rich, meaning that deep beneath its scorching surface, the immense pressures have likely compressed a vast portion of its interior into a crystalline structure, a layer of diamond hundreds of miles thick. We are talking about a planet that could, in a literal sense, be one gigantic jewel. Yet this diamond comes at a terrible price. 55 Cancri orbits its host star with such intimacy that a single year, one full trip around, lasts a mere 18 hours. This proximity locks the planet in a gravitational embrace so tight that one side likely permanently faces the star, creating a world of eternal day and eternal night. The day side is a furnace with surface temperatures soaring above 4,000 degrees Fahrenheit, hot enough to melt iron and vaporize rock. Current research suggests the surface may not be solid at all, but a global, churning ocean of molten lava, shimmering under the light of its blindingly close sun. The night side, while cooler, is still unimaginably hostile. This bizarre world forces us to rewrite the textbook on what is possible. We once thought of planets in simple categories, rocky like Mars or gaseous like Jupiter. 55 Cancri defies that, presenting a third archetype, a carbon planet, a concept that was purely theoretical until we found it. Right now, telescopes like the James Webb Space Telescope are trying to peer through the seething heat to analyze its atmosphere, if it even has one that can survive such stellar fury. They search for the chemical signatures of this diamond world, a jewel glowing in the cosmic dark, reminding us that the universe's treasures are often found in the most infernal places. Our diamond world is a prisoner of its star, but there exists an entire class of planets that know no such master. They are the cosmic drifters, the rogue planets, and their numbers are staggering. Recent surveys using a technique called gravitational microlensing have revealed a silent deluge of these nomads, suggesting a population so vast it may outnumber all the stars in the Milky Way. Imagine our galaxy not as a collection of solar systems, but as a dark sea filled with more wandering, starless worlds than there are lighthouses. These are not planets ejected from their homes in violent events, though some certainly are. Many are believed to have formed alone in the cold collapse of isolated gas clouds too small to ignite into stars. They are born into darkness and will live their entire existence in it. Picture such a world, a dark sphere of rock and ice adrift in the interstellar void. Its surface, if it has one, is a frozen wasteland under a sky of unbroken black, punctuated only by the distant, unmoving pinpricks of galaxies. No sunrise will ever warm its face, yet within some of these frozen wanderers a flicker of life may persist. Tidal forces from a large moon or the slow radioactive decay of elements in their cores could provide enough internal heat to maintain a vast global ocean beneath a thick crust of ice. In the eternal night, in absolute darkness, a subsurface sea might churn with geothermal vents, creating an isolated pocket of potential habitability cut off from the rest of the universe. These are not science fiction, they are a statistical reality inferred from the subtle bending of starlight. When a rogue planet passes in front of a distant star, its gravity acts as a tiny lens, briefly magnifying the star's light in a telltale spike. These fleeting events are our only window into this hidden population. So as you look up at the starry sky, consider the profound emptiness between those points of light. It is not empty at all. It is teeming with invisible worlds, a ghostly traffic of frozen spheres on billion-year journeys, carrying their secrets and perhaps their hidden oceans through the endless cold. While rogue planets drift in darkness, other objects are being violently expelled into the void at unimaginable speeds. Streaking out from the very heart of our galaxy is a class of celestial fugitives known as hypervelocity stars. The current champion is a star designated S5HVS1, a solitary sun racing through the halo of the Milky Way at over 1,700 kilometers per second. At that speed, you could travel from Earth to the Moon in under 4 minutes. This star is not merely moving fast, it is moving fast enough to achieve the ultimate escape. The gravitational pull of our entire galaxy is not strong enough to hold it, and so it is on a one-way trip out into the endless black between galaxies. Its origin story points to a single, terrifying culprit, the supermassive black hole at our galactic center, Sagittarius, a star. The most plausible scenario is a deadly dance that began with 2 stars orbiting each other as a binary pair. This duo ventured too close to the black hole's event horizon. In a gravitational maneuver of staggering violence, one star was captured by the black hole's immense pull, while its partner received a catastrophic slingshot boost, a transfer of orbital energy so immense it was catapulted away like a stone from a giant sling. We are witnessing the aftermath of that event, a star hurled from the most dangerous place in the galaxy, now carrying a velocity that spells permanent exile. Its future is a lonely one. It will cross the gulf of intergalactic space, its light slowly fading as it leaves every familiar star and nebula behind, destined to grow cold and dark in the profound isolation between galaxies. This is not a singular accident. Astronomers have spotted others on similar trajectories. Right now, these stellar projectiles are tracing their silent, high-velocity arcs out of the Milky Way, permanent refugees from a close call with the ultimate cosmic monster. This exile into the void is a one-way journey, but our entire galaxy is on a collision course of its own. We are not adrift, we are being pulled. Every galaxy in our local neighborhood, including the Milky Way, is moving with a peculiar velocity, all streaming toward a single, invisible point in the constellation Centaurus. This phenomenon is called the Great Attractor, and it represents one of the most significant gravitational mysteries in our cosmic backyard. Something with the mass of tens of thousands of Milky Way galaxies is pulling us and everything around us toward it at over 2 million kilometers per hour. The sheer scale of this motion is humbling, a river of galaxies all flowing toward a hidden waterfall. Yet for decades the source of this immense pull remained frustratingly obscured. The Great Attractor lies in the zone of avoidance, a region of the sky hidden behind the thick dust and stars of our own galaxy's central bulge. It was like trying to find a distant city while staring directly into the glare of a nearby spotlight. But modern astronomy, particularly X-ray observatories like XMM Newton, has begun to peer through the cosmic fog. By looking in wavelengths that can penetrate dust, these missions have revealed that the Great Attractor is not a single monstrous object. Instead, it appears to be an immense confluence of mass, a supercluster of galaxies known as the Norma Cluster, sitting at the heart of an even larger structure called the Laniakea supercluster, of which we are a distant part. Yet, even this colossal gathering of galaxies does not fully account for the strength of the pull we feel. There seems to be even more mass, perhaps in the form of vast amounts of dark matter, concentrated in that direction. So the motion we are caught in is a double mystery, a pull toward both a visible and an invisible source of gravity. Right now, as you listen, our galaxy is riding this immense cosmic current, drawn toward a point we are still struggling to see, a reminder that the largest forces shaping our fate can be the ones hidden in plain sight. That immense current pulling our galaxy is a grand, slow motion, but some cosmic mysteries arrive with a frantic, flickering urgency. Among the hundreds of thousands of stars monitored by the Kepler telescope, one stood out not for its constancy, but for its bizarre and erratic dimming. KIC 8462852, better known as Tabby's star or Boyajian star, remains a beacon of cosmic confusion. This otherwise ordinary star, slightly larger and hotter than our Sun, does something no other star we know of does. It dims in wild, unpredictable ways. Most planet hunting relies on the gentle, periodic dip caused by an orbiting world passing in front of its star, a tiny shadow repeating like clockwork. Tabby's star is nothing like that. Its light curves are chaotic. It has experienced sudden drops in brightness of up to 22%, a staggering amount that would require an object half the width of the star itself to block the light. Even stranger, these dips are not symmetrical or clean. They are jagged, as if something with a complex, irregular shape is drifting through our line of sight. Then, adding to the puzzle, long-term data shows the star has also been undergoing a gradual, secular dimming over the past century. Something is both sporadically and steadily blocking its light. The initial discovery sparked a frenzy of theories, from the mundane to the extraordinary. Could it be a vast, swarming family of comets breaking apart and casting immense shadows? Perhaps it is the aftermath of a cataclysmic planetary collision, leaving a sprawling cloud of debris in a chaotic orbit. And of course, the most tantalizing idea emerged. Could this be evidence of alien engineering on a staggering scale? A partially constructed Dyson sphere, a swarm of solar collectors built by an advanced civilization to harness the star's energy. That hypothesis, while thrilling, is considered a last resort by scientists. The current leading explanations are firmly in the realm of natural astrophysics, but they are no less strange. The most favored model involves a complex, dusty debris ring, perhaps stirred by the gravitational influence of an unseen planet, creating clumps and arcs of material that transit the star in these bizarre patterns. Another points to intrinsic stellar activity, though the star's spectrum shows no signs of the violent outbursts that would typically cause such dimming. The crucial point is this: the mystery is alive. Tabby's star has not settled down. New dips in its brightness have been observed since the initial discovery, each one a fresh piece of data for astronomers to scrutinize. It is an active laboratory of the weird, a reminder that sometimes the most profound puzzles are not hidden in the distant past, but are playing out in real time, in the flickering of a single, unassuming point of light over 1,000 light-years away. The flickering of a single distant star is a small puzzle, but our own galactic home hides evidence of a cataclysm on a truly gargantuan scale. Emerging from the very heart of the Milky Way, two colossal structures balloon out into intergalactic space, each one a ghostly, gamma-ray emitting lobe stretching 25,000 light-years above and below the galactic plane. These are the Fermi bubbles, and they are so immense they dwarf our entire galaxy's visible disk. If human eyes could see their faint, high-energy glow, they would dominate the night sky, a pair of symmetrical hourglasses of light centered on the constellation Sagittarius. Their discovery was a shock, a reminder that even our own cosmic neighborhood holds monumental secrets hidden in plain sight. They are not made of stars or glowing gas as we typically see, but are filled with extremely hot magnetized plasma, emitting the most energetic form of light in the universe. This points to a violent, explosive origin. The leading theory points a finger squarely at the dormant monster at our galactic center, the supermassive black hole Sagittarius, a star. Sometime in the past few million years, a relatively recent event on cosmic timescales, this black hole likely awoke from its slumber in a spectacular fashion. It may have entered a quasar-like phase, gorging on a tremendous amount of infalling gas and matter. As this material spiraled into the abyss, unimaginable energies were released, not from the black hole itself, but from the frenzied maelstrom of material around it. Powerful jets of particles and radiation, moving at nearly the speed of light, would have blasted perpendicularly out from the galactic core, punching through the galaxy's gas and inflating these two gigantic bubbles like cosmic balloons. An alternative idea suggests a different kind of frenzy, a period of such intense star formation and subsequent supernova explosions in the galactic center that the combined stellar winds created a similar titanic outflow. Either scenario paints a picture of a Milky Way that was once a far more violent and active place. The most profound thought is that this event is not truly over. The bubbles are still there, their hot, thin plasma slowly cooling and dissipating its energy into the cold void. We are living in the long, quiet aftermath of a galactic-scale eruption, its fading echoes still visible as a pair of faint, monumental ghosts in the gamma-ray sky, a permanent scar from a time when our galaxy's heart roared with fire. Even our most familiar celestial landmarks are not immune to the universe's strange behavior. The Pleiades cluster, the Seven Sisters, is one of the most recognizable star patterns in the night sky, a sparkling knot of blue stars visible to the naked eye. For generations, astronomers have mapped and measured its brightest members, assuming their light was constant. But a recent dive into historical records has revealed a startling anomaly, a secret hiding in plain sight for over a century. The star Atlas, one of the cluster's prominent leaders, was not always as bright as it appears today. Photographic plates and observer logs from the early 1900s consistently show Atlas shining noticeably dimmer than its current magnitude. This is not a mistake in old data, it is a documented change. The star we see now is intrinsically brighter than the star our great-grandparents saw. So what caused a star in a famous, stable cluster to gradually brighten over decades? The answer points to a bizarre and exotic type of star. Atlas is now classified as a chemically peculiar Mercury-manganese star. This means its surface is not a uniform mix of elements like our Sun's, but is instead marbled with strange, heavy metals concentrated in giant spots or bands by its own magnetic fields and slow rotation. Imagine a star with continents of exotic elements floating on its surface. The leading theory is that Atlas has a vast, bright region on its surface, a kind of stellar hotspot rich in these peculiar elements. As the star slowly spins, completing a rotation only once every few years, this brilliant continent rotates in and out of our view from Earth. When it faces us, the star appears brighter. When it turns away, the star dims. We are not witnessing a sudden eruption, but a slow, decades-long pulse, a cosmic lighthouse with an incredibly slow beam. This means the change recorded since 1900 is likely just one phase of a very long cycle. Right now, we are probably near a peak in Atlas's brightness, but in another few decades, it may begin to fade again as that brilliant spot rotates to the star's far side. This transforms a fixed point in our sky into a long-term variable star, a subtle reminder that even the ancient Seven Sisters are engaged in their own slow, mysterious dance, their light telling a story that unfolds over a human lifetime. The slow pulse of a star's light is a gentle rhythm, but the cosmos also crackles with sudden, unimaginable violence. Right here on Earth, inside the very storms that bring us rain, nature is creating some of the most energetic bursts of radiation in the solar system. They are called terrestrial gamma-ray flashes, and for a fraction of a millisecond, they outshine the sun in gamma rays. These are not coming from deep space, they are born in the heart of our own thunderstorms. When lightning prepares to strike, the intense electric fields at the top of a thundercloud can become so powerful they act like a natural particle accelerator. Electrons are ripped from air molecules and hurled upward at nearly the speed of light. When these relativistic electrons slam into other atoms in the thin upper atmosphere, they screech to a halt, and that sudden deceleration releases a torrent of gamma rays, the same deadly photons produced by nuclear reactions and collapsing stars. The beam is so focused and energetic that it rockets straight out of the atmosphere and into space where satellites can detect it. Incredibly, this process also creates a fountain of antimatter. The gamma rays can spontaneously transform into pairs of electrons and their antimatter counterparts, positrons, which are then caught in Earth's magnetic field and annihilate in a flash of more gamma rays. So, a common thunderstorm, a phenomenon we watch from our windows, is secretly a cosmic-scale particle gun, firing beams of pure energy and antimatter into the void above us. It is a stunning reminder that the universe's most extreme physics is not always light years away. It is happening right over our heads. Yet, this terrestrial fury is just a miniature version of a far more sinister and permanent storm. Thousands of light years away, in the constellation Sagittarius, a dead star is conducting a similar but apocalyptic experiment on a stellar scale. This is the Black Widow pulsar, a millisecond pulsar spinning hundreds of times per second, blasting its surroundings with a hurricane of radiation and a supersonic wind of charged particles. It earned its name from its horrifying behavior. Like its arachnid namesake, this pulsar is slowly consuming its mate. It is locked in a tight, deadly orbit with a small, brown dwarf star, a failed star barely larger than Jupiter. The pulsar's intense beam of energy and relentless particle wind is bombarding one hemisphere of its companion, heating it to over 10,000 degrees and literally blasting its surface material away into space. Astronomers can see a vast cometary tail of vaporized star stuff trailing behind the doomed brown dwarf as it orbits. This is not a quick death, it is a slow, agonizing evaporation. The pulsar is both frying and sandblasting its partner, stripping away layers of gas that spiral down onto the pulsar itself, a process that actually helps keep the dead star spinning at its incredible speed. We are witnessing the final stages of a cosmic murder, a predator using its own intense radiation to dissolve its prey atom by atom. The contrast is profound. On Earth, a temporary atmospheric phenomenon creates a fleeting spike of antimatter. In deep space, a permanent stellar corpse uses a constant, focused torrent of the same fundamental forces to systematically annihilate another world. One is a natural, if terrifying, electrical event. The other is the ultimate expression of gravitational predation, a relationship where one body's existence is entirely dependent on the destruction of another. That pulsar's deadly radiation is a product of a stellar death, but the birth of galaxies themselves is now under a strange new scrutiny. A single, fuzzy red dot in a deep field image from the James Webb Space Telescope is causing a quiet uproar among cosmologists. This object, designated ZFUDS-7329, is not just another distant galaxy. It is an impossibility, a cosmic anomaly that seems to break the rules of how the universe built its largest structures. Based on its redshift, its light has traveled for over 13 billion years to reach us, meaning we are seeing it as it was when the universe was only about 800 million years old, a mere infant by cosmic standards. Yet, analysis of its starlight suggests this young galaxy contains a staggering amount of mass, the equivalent of hundreds of billions of stars like our Sun. This presents a profound and baffling contradiction. According to our best models of cosmic evolution, galaxies grow slowly. They start small, within halos of invisible dark matter that gently pull in gas over billions of years, allowing stars to form in a gradual, steady process. A galaxy this massive, this early, simply should not exist. It is like finding the ruins of a modern skyscraper in an archaeological dig of a Stone Age settlement. The building materials and the time required to assemble it are not there. The core of the problem lies with dark matter. Our entire understanding of galaxy formation hinges on these invisible gravitational scaffolds. Small dark matter halos form first after the Big Bang, and they slowly merge together to build larger structures which then attract the gas that becomes stars. This process takes time, a lot of it. ZFUDS-7329 appears to have skipped several steps, assembling a colossal collection of stars in a fraction of the time our models allow. Did dark matter behave differently in the early universe? Could there have been a faster, more violent pathway to galaxy formation that we have not accounted for? Or is there something we are misunderstanding about the measurements themselves? This is not a settled mystery. It is a live controversy with papers being written and debated right now. Some scientists are re-examining the data, checking if the galaxy's distance or mass has been misinterpreted. Others are running frantic new supercomputer simulations, trying to see if any tweak to the standard model can produce such a behemoth so quickly. What we are witnessing is the scientific process in real time, confronting an observation that refuses to fit. This faint red smudge is more than a galaxy, it is a challenge. It forces us to ask whether the story we have told about the dawn of galaxies is complete, or if the early universe was a far stranger, more tumultuous and efficient place than we ever dared to imagine. While the early universe presents one kind of formation mystery, a stunning spiral closer to home is demonstrating a very different kind of cosmic productivity. The Whirlpool galaxy, known as M51, is not just a beautiful face on spiral for amateur astronomers, it is a supernova factory. In just the last 20 years, this single galaxy has produced two brilliant, observed stellar explosions, supernova 2005 CS and supernova 2011 DH. That is an astonishingly high rate, a double blast of cosmic fireworks in a cosmic blink. To understand why, you need to look not just at the whirlpool itself, but at the distorted, smaller galaxy seen tugging at the end of one of its majestic spiral arms. This is NGC 5195, and the two are locked in a slow, gravitational dance. As they interact, their mutual gravity acts like a giant stirring spoon in a cosmic pot. Vast clouds of gas and dust within the whirlpool are violently compressed and shocked. This compression is the ultimate trigger for star birth, igniting a frenzy of new stellar formation across the galaxy's spiral arms. But there is a dark side to this stellar baby boom. When stars form in such a frenzy, many of them are born as absolute behemoths, stars with 8 times the mass of our Sun or more. These giants live fast and die young. They burn through their nuclear fuel in just a few tens of millions of years, a mere heartbeat in cosmic time, before their cores collapse in the cataclysmic explosions we see as supernova. So, the two brilliant supernovae we witnessed in 2005 and 2011 were not random accidents. They were the direct, inevitable consequence of a galactic collision that likely triggered their births millions of years earlier. We are seeing the delayed payoff of that interstellar violence. Right now, the interaction continues. The whirlpool's arms are still lit up with the blue glow of countless young, massive stars, many of which are future supernova just waiting their turn. This galaxy offers us a real-time lesson in cause and effect on a galactic scale, a beautiful demonstration that even destruction as total as a supernova is part of a larger cycle of creation and renewal, driven by the relentless pull of gravity. These galactic collisions and stellar fireworks are all part of a much grander architecture. For decades, cosmologists have theorized that galaxies are not scattered randomly like isolated islands, but are strung along vast, invisible threads of dark matter, forming a cosmic web that stretches across the emptiness. This is the fundamental skeleton of the universe, a filamentary structure that dictated where galaxies would form after the Big Bang. Until recently, this web was a theoretical blueprint, a ghostly framework inferred from the positions of galaxies but never directly seen. Now that is changing. Astronomers are beginning to capture its faint, diffuse glow, a process akin to turning on a blacklight in a dark room to reveal the hidden patterns on the walls. The key lies in a specific type of light emitted by hydrogen gas, the most abundant element in the cosmos, known as Lyman alpha emission. When hydrogen atoms in the thin gas of intergalactic space are energized by the ultraviolet light from young stars and quasars, they re-emit this energy as a very particular wavelength of ultraviolet light. Over billions of years of cosmic expansion, this light stretches or redshifts into the visible spectrum. By using incredibly sensitive instruments on the world's largest telescopes and employing special narrowband filters designed to isolate this specific stretched glow, researchers can now take pictures that subtract the light from all the stars and galaxies. What remains is an eerie, fluorescent map of the gas itself. The images reveal a faint, interconnected network of luminous tendrils, tracing the predicted dark matter filaments and highlighting the vast, empty voids between them. This glow is not just a static map of the universe's bones, it is a sign of dynamic life. This cosmic web is the universe's circulatory system. The gas within these filaments is slowly, relentlessly flowing along these gravitational channels, funneling the raw fuel for star formation into the hungry galaxies that sit at the intersections of the web. We are witnessing the primary delivery mechanism for cosmic construction. Every galaxy, including our Milky Way, grew by sipping from these rivers of primordial hydrogen. The fact that we can now begin to see this glow is a technological triumph that transforms an abstract concept into a visible, dynamic reality. It means we are no longer just inferring the universe's structure from the dots of light. We are starting to see the luminous connective tissue that binds it all together, watching the very highways that built everything we see. That glowing cosmic web delivers the building blocks of worlds, but not every planet gets to keep its gift. Orbiting a dim red dwarf star just 33 light-years away is a world caught in the act of disintegration. GJ436b is a hot Neptune, a gaseous planet roughly the size of our own Neptune, but orbiting so close to its star that its year is a blistering 2.6 Earth days. This proximity has sentenced it to a spectacular demise. The planet's outer atmosphere is not merely hot, it is being violently stripped away by the relentless stellar wind and intense ultraviolet radiation from its host star. The Hubble Space Telescope did not just detect this evaporation, it captured its ghostly signature. Observations revealed a giant, comet-like envelope of hydrogen boiling off the planet and streaming behind it, forming a colossal tail that stretches for millions upon millions of miles. We are not looking at a static world, but at a dynamic, leaking globe. The process works like a cosmic pressure cooker. The star's energy heats the upper layers of the planet's hydrogen atmosphere to the point where individual atoms gain enough velocity to escape the planet's weakened gravity. They are then swept away by the stellar wind, sculpted into that immense trailing plume. The scale is staggering. The planet is losing its mass at a rate of up to 1,000 tons per second. While that sounds catastrophic, and it is, this evaporation is a slow-motion event on a human timescale. It will take billions of years for the star to completely strip the planet down to its possible rocky core, transforming it from a gaseous world into a barren, superheated cinder. Yet the significance is immediate. GJ436b offers us a front-row seat to a phase of planetary evolution we had only theorized. It is a dramatic, visible demonstration of stellar irradiation's power to fundamentally alter a world, literally blowing away its sky. This bizarre, tail-trailing planet is a preview of a possible future for many worlds orbiting too close to their suns, a reminder that in the cosmos, even a planet's atmosphere is not a permanent possession, but a temporary veil held against a stellar hurricane. But the grand flow of the cosmic web might be just a local current within a far stranger and more controversial river. Beyond the pull of the Great Attractor, astronomers have detected a motion so vast and perplexing it threatens to rewrite our understanding of the cosmos itself. They call it the dark flow. Analysis of the cosmic microwave background, the afterglow of the Big Bang, reveals a haunting pattern. Hundreds of massive galaxy clusters, scattered across billions of light-years, appear to be streaming in a coherent, bulk motion toward a single point in the constellations Centaurus and Hydra. This is not the gentle drift of galaxies within the cosmic web. This is a vast, collective drift of entire superclusters, all moving in lockstep like leaves caught on a hidden river. The most baffling part is the scale. This motion seems to extend to the very limits of our observable universe, and its source cannot be explained by any visible mass, not by the Great Attractor, not by the Laniakea supercluster, not by any known structure. The gravitational pull required to cause such a flow would have to come from something unimaginably massive lying far beyond the edge of everything we can see. The implication is staggering. It suggests our entire observable universe, all 93 billion light-years of it, might itself be moving, tugged by the gravity of something truly outside our cosmic horizon. Picture our cosmos not as an infinite expanse, but as an island in a far greater sea, feeling the tide from a neighboring island of reality we can never see. This idea, of course, is met with profound skepticism. Many astronomers argue the signal is a statistical fluke, an artifact of how we subtract the background glow of our own galaxy's motion from the delicate microwave data. They point to newer analyzers that fail to confirm the effect with the same strength, suggesting it might be a ghost in the machine, a remnant of incomplete data cleaning rather than a fundamental cosmic truth. The debate is fierce and ongoing, a perfect example of science at the frontier. One side sees the hint of a multiverse, a landscape of other universes exerting a gravitational pull on our own. The other sees a measurement error that will fade with better instruments. Right now, this mystery hangs in the balance. New data from observatories like the Euclid Space Telescope will provide even more precise maps of cosmic structure and motion, offering a chance to confirm or finally lay to rest the claim of the dark flow. We are left with a profound question. Are we seeing the first evidence of a reality beyond our own, or simply the echoes of our own imperfect vision? It is a controversy that touches the very nature of existence, asking if our universe is truly alone. While the dark flow hints at mysteries beyond our horizon, a star within our own cosmic neighborhood staged a death so bizarre it seemed to defy the laws of physics. In 2014, astronomers with the Intermediate Palomar Transient Factory spotted a supernova erupting in a galaxy 500 million light-years away. They catalogued it as IPTF14 HLS, expecting a standard, if dramatic, end for a massive star. For the first 100 days, it behaved perfectly, brightening and then fading as a colossal explosion should. But then it did something unprecedented. Instead of continuing its fade into darkness, the supernova's light curve plateaued, and then, impossibly, it began to grow brighter again. Over the next 600 days, this star exploded not once, but at least 5 separate times, each outburst a violent surge in brightness as if the star was resurrecting itself only to die again. It became known as the zombie star, a stellar remnant that refused to stay dead. The energy output was staggering, releasing at least 5 times more energy than a typical supernova, and it remained luminous for over 3 years, an eternity for such events. This was not a simple hiccup, it was a full-blown rebellion against every established model of stellar death. A normal core collapse supernova is a single, catastrophic event. The star's core runs out of fuel, gravity wins in an instant, and the outer layers come crashing down before rebounding in one titanic explosion that utterly destroys the star. IPTF-14 HLS suggested something else entirely, a star that could somehow survive multiple blasts of apocalyptic force. The leading theory to explain this nightmare is as extreme as the observation itself, a pulsational pair instability supernova. This occurs in stars of truly monstrous size, between 100 and 130 times the mass of our Sun. In their final years, the cores of these behemoths become so hot that light itself begins to behave dangerously. Photons of gamma radiation bouncing around in the stellar furnace spontaneously transform into pairs of electrons and their antimatter counterparts, positrons. This process, called pair production, is a stealthy thief. It siphons away the radiation pressure that was holding the star up against its own immense gravity. Without that outward push, the core begins to collapse, but in this unique mass range, the collapse is not instantly fatal. Instead, it heats the core even further, reigniting nuclear fusion in a furious, explosive burst that blows off the star's outer layers in a massive eruption. This releases tremendous energy, but it stops short of completely destroying the star. The core survives, exposed and shrunken. Then, over months or years, the process repeats. The star, now a little lighter, continues its life until pair instability triggers another partial collapse and another violent eruption. It is a star dying in agonizing, explosive installments. IPTF-14 HLS is the first and only candidate we have ever seen for this theoretical death spiral. We witnessed a cosmic giant fighting its own gravity in a series of last stands, a final, flickering battle between creation and annihilation playing out over years instead of moments. It forces us to accept that even something as fundamental as a star's death can come in forms we are only beginning to comprehend. A reminder that the universe's rulebook still has pages we have not yet turned. Our own moon, that silent and familiar companion, is not the unchanging desert it appears to be. It flickers. For centuries, astronomers, both amateur and professional, have reported brief, enigmatic flashes of light, sudden patches of color, or temporary hazes obscuring features on the lunar surface. These are transient lunar phenomena, or TLPS, and they are happening right now, a live mystery in our celestial backyard. These events are not the predictable glint of sunlight off a mountain peak. They are anomalous, unpredictable, and fleeting, sometimes lasting only seconds. The catalogue of observations is rich and strange, a history of momentary lunar fireworks. There are pinpoint flashes like a cosmic camera going off in the darkness. There are diffuse, reddish glows that linger in a crater for an hour. There are even reports of violet or blue tints and mysterious veils that momentarily blur the sharp edges of lunar valleys. For a long time, these reports were dismissed as tricks of the eye, atmospheric distortion, or even wishful thinking. But with modern technology, including dedicated lunar monitoring telescopes and even spacecraft in orbit around the moon, the evidence has become undeniable. The moon is an active, dynamic world in subtle and surprising ways. So what causes these ghostly lunar lights? Scientists point to a menu of fascinating natural processes. The most straightforward are meteoroid impacts. The Moon has no atmosphere to burn up incoming space rocks, so even tiny pebbles strike the surface at tremendous speeds, vaporizing on impact in a brief, hot flash of light. These are common and can be seen by anyone with a modest telescope during meteor showers. A more enigmatic cause is outgassing. The Moon's interior is not completely dead. Radioactive decay in its deep rock can generate small amounts of gas like radon or argon. This gas, trapped for eons, might find a microscopic crack or fissure and escape to the surface in a sudden, localized puff. When this gas plume reaches the vacuum of space, it could briefly scatter sunlight, creating a faint, shimmering haze or glow before dissipating into nothing. Then there is the truly exotic possibility, electrostatic dust levitation. The lunar surface is constantly bombarded by solar radiation, which gives it a strong electric charge, particularly along the terminator line between day and night. This charge can cause the incredibly fine, razor-sharp lunar dust to literally lift off the ground, levitating just above the surface. If a large patch of dust were to become charged and rise in a cloud, it could create a temporary, shimmering obscuration, a ghostly veil dancing in the sunlight before settling back down. The incredible part is that you, with a backyard telescope and patience, could witness one of these events. Amateur astronomers around the world contribute vital data to TLP studies, keeping a watchful eye on the silent seas and cratered highlands. Every confirmed flash or glow is a piece of a puzzle, reminding us that even the most familiar object in our night sky is a world with its own secret, flickering life, a stage for silent, transient performances that have only just begun to be understood. Even as we watch the Moon for fleeting flashes, a far more enduring mystery tugs at the very edge of our solar system. The Kuiper belt, that icy realm beyond Neptune, is not behaving as it should. The orbits of its most distant inhabitants, small frozen worlds like Sedna, tell a strange gravitational story. They are clustered together, their elongated paths all pointing in roughly the same direction and tilting in a similar way, a cosmic alignment that should be statistically impossible if only the known planets are pulling on them. It is as if a hidden conductor is orchestrating their dance from the wings. This bizarre orbital clustering is the primary clue pointing to the existence of a hypothetical giant, a world we call Planet 9. This is not a wild guess, it is a prediction born from precise gravitational mathematics. To shepherd these distant objects into such a peculiar configuration, something with substantial mass must be out there, its gravity sculpting their orbits over billions of years. Based on the observed effects, astronomers calculate this hidden world would be a super-Earth or a mini-Neptune, with a mass roughly 5 to 10 times that of our own planet. Its orbit, however, would be nothing like the neat circles of the inner planets. Planet 9 is thought to follow a highly elliptical or oval-shaped path that takes it staggering distances from the Sun. At its closest approach, it might come within 300 astronomical units, that is 300 times the distance from Earth to the Sun. But at its most distant, it could swing out to over 1,000 astronomical units, drifting in the profound cold of deep space for millennia before swinging back inward. This incredible distance, combined with its likely dark, icy surface that reflects very little sunlight, is why we have not spotted it yet. It is a ghost felt only by its gravitational whispers. The search for this phantom world is one of astronomy's great modern detective stories. Teams are using the world's most powerful telescopes, like Subaru in Hawaii, to scan vast swaths of the sky where calculations suggest it might be hiding. They are looking for a single, slow-moving point of light against the fixed background of stars. An incredibly challenging task given the immense area to cover and the object's predicted faintness. Every month that passes without a discovery refines the search, narrowing down the possible locations. We are living in a unique moment, a time when we have strong, indirect evidence for a major new planet in our own cosmic backyard, yet we cannot point to it in the sky. The discovery of Planet 9 would be a monumental event, rewriting the map of our solar system and offering a stunning example of how science works, not just by looking, but by listening to the subtle, persistent clues written in the silent motions of distant ice. The ghostly pull of a hidden planet is a subtle whisper, but in the winter of 2019, a star in our own galactic neighborhood screamed for attention. Betelgeuse, the brilliant red supergiant marking Orion's shoulder, began to fade, not subtly, but in a dramatic, unprecedented plunge that saw it lose 2/3 of its normal brightness over a matter of months. By February 2020, this familiar beacon, one of the 10 brightest stars in our sky, had grown so dim it was barely visible to the naked eye. The astronomical world held its breath. It was Betelgeuse, a star known to be in its final death throes, about to explode in a supernova visible even in daylight. The speculation was electric, a collective moment of cosmic anticipation. We were potentially watching the final act of a stellar giant that had shone for just 8 million years, a cosmic blink compared to our sun's lifespan. The event, dubbed the Great Dimming, became a global spectacle, a reminder that the night sky is not a static painting. Then, just as mysteriously as it dimmed, Betelgeuse began to recover. The supernova had not arrived, so what caused this dramatic flicker? The answer, revealed by detailed observations from the Hubble Space Telescope and other observatories, was both simpler and more fascinating than an imminent explosion. Betelgeuse is a pulsating variable star, its size and brightness naturally changing over periods of months and years. In late 2019, it ejected an enormous plume of superheated plasma from its southern hemisphere. This material did not just drift away. As it traveled into the colder regions of space, it cooled and condensed into a colossal cloud of dust, literally stardust made solid. This titanic dust cloud, a fragment of the star itself, drifted directly in front of Betelgeuse from our vantage point on Earth, acting like a cosmic lampshade and dimming its light. We did not witness the prelude to a supernova, but something equally instructive, a violent episode of mass loss. This is how red supergiants die, not with a single bang, but in a series of furious outbursts where they shed their outer layers into space. The Great Dimming was a spectacular preview of that process. The supernova will come, and when it does, Betelgeuse will blaze brighter than a full moon for weeks, visible in broad daylight. But that cataclysm could happen tomorrow, or it could happen in 100,000 years. The star's final schedule remains one of the universe's great unscheduled events, a sleeping giant whose every cough and whisper we now watch with rapt attention. Betelgeuse's dimming was a local event, a single star's cough echoing across a few hundred light years. But the universe itself is now humming a tune of far greater consequence, a low-frequency vibration felt not with our ears but through the very fabric of reality. For over 15 years, a project called NanoGrav, the North American Nanohertz Observatory for Gravitational Waves, has been listening. They did not use microphones or traditional telescopes, but an array of the most precise clocks in the galaxy, pulsars. These spinning neutron stars beam radio waves with metronomic regularity, creating a galactic network of natural timekeepers. By meticulously monitoring the arrival times of these pulses from dozens of pulsars across the Milky Way, scientists watched for a specific, predicted distortion. If a gravitational wave, a ripple in spacetime itself, passed between us and a pulsar, it would minutely stretch and compress the distance the radio waves had to travel, causing the pulse to arrive a fraction of a second early or late. For years, the data from individual pulsars showed nothing but random noise. But when the signals from the entire array were combined, a pattern emerged from the chaos. Not a single chirp from a cataclysm, but a pervasive, low rumble. The universe is filled with a gravitational wave background, a constant hum resonating through the cosmos. This hum is not the sound of one event, but the combined chorus of millions, perhaps billions, of supermassive black hole binaries. Across the universe, in the hearts of merged galaxies, pairs of these unimaginably heavy objects, each with the mass of millions or billions of suns, are locked in orbital dances that last for eons. As they spiral ever closer, they churn the space-time around them, sending out ripples that travel at the speed of light across billions of light-years. Individually, each binary signal is too faint and too low in frequency for our current detectors like LIGO to hear. LIGO listens for the high-frequency chirps of stellar mass black holes merging in a final, violent second. The nanograv signal is the opposite, the cumulative drone of countless cosmic giants waltzing in ultra-slow motion, their orbits taking years to complete, their gravitational waves with wavelengths so long they span light years. Think of it like standing by the ocean. You cannot hear a single water molecule moving, but the combined motion of trillions creates the relentless background roar of the surf. This hum is that surf, but for space-time itself. It is a real-time soundtrack to the universe's largest-scale structure, proof that the cosmos is not silent or static, but is a dynamic, vibrating arena where the most massive objects are constantly stirring the void. We have just opened our ears to a new sense, allowing us to perceive a fundamental layer of cosmic activity that was forever hidden before. This background hum is not the end of the story, but a beginning, a new window through which we will listen to the mergers of entire galaxies and probe the very first moments of time itself. These bizarre events are not random anomalies. They are threads woven into a single, immense tapestry, each one revealing a different part of the universe's grand, interconnected life cycle. The stellar vampire draining its companion will one day explode, seeding its neighborhood with heavy elements forged in that final blast. That enriched debris, scattered by the supernova's fury, will eventually mix with the cold gas flowing along the cosmic web. Later, when galaxies like the whirlpool collide, that same enriched material will be compressed, igniting the birth of a new generation of stars and planets. Even the destructive fury of a rogue black hole or a hypervelocity star carves pathways and stirs the cosmic pot, influencing the conditions for future evolution. The supermassive black holes at the centers of galaxies, whether dormant like Sagittarius, a star, or active like the engine that created the Fermi bubbles, act as gravitational anchors and regulators, their growth and mergers dictating the fate of entire galactic ecosystems. This is the profound synchronicity of the cosmos. A star's death is a planet's raw material. A galactic collision is a stellar nursery's trigger. The ghostly pull of dark matter shapes the rivers of gas that feed it all. Every strange event we have witnessed, from the diamond world baking in its star's glare to the phantom galaxies frozen in time, is a single frame in a continuous, universe-wide movie. To understand one is to glimpse the mechanics of all. These are not distant, irrelevant curiosities. They are the fundamental processes of construction and destruction that built the atoms in our bodies and the planet under our feet. The universe is not a static museum display. It is a living, breathing, and often violent engine of change, and its story is unfolding in real time all around us. This grand cosmic tapestry, woven from stellar vampires and phantom galaxies, rogue planets and humming spacetime, is our shared reality. We have traveled from the heart of our own galaxy to the edge of the observable universe, witnessing 25 events that defy simple explanation. Each one is a testament to a single, profound truth. The cosmos is not a still painting hanging in a museum. It is a vibrant, chaotic, and astonishingly weird movie, and every single one of us has a front-row seat. The sky above you is not a passive dome. It is a dynamic stage where diamonds are forged in hellfire, where invisible giants sculpt rivers of stars, and where the echo of the Big Bang still vibrates through everything. This is not a story about a distant past, but about a continuous present. The universe is alive with process, a constant churn of creation and destruction playing out on scales that both humble and inspire. So the next time you step outside on a clear night, look up, See not just points of light, but possibilities. See the vampire star stealing its final meals, the runaway black hole painting its trail, the frozen breath of a dying sun. Let that wonder sink in and let it fuel your curiosity. The greatest discoveries are still out there, waiting for the next generation of observers, thinkers, and dreamers to piece them together. We would love to hear which of these bizarre events captured your imagination the most. Was it the diamond planet, the zombie star, or the cosmic web's faint glow? Tell us in the comments below. If you want to join us for more deep dives into the mysteries of space, make sure to subscribe. The universe's next bizarre chapter is already being written, and we cannot wait to explore it with you.